You can ask your doubts if you have. Question 1, any doubt? Question 1 and 2. Question 1 and 2, any doubt? Question 1. For these type of questions, usually you have to write first the equation. As you can see, 3.7 grams of a sample of a copper 2 carbonate is added to 25 cm cube of 2 mole per dm cube hydrochloric acid. Which volume of a gas is produced under room condition? So the first thing, because there's a reaction, so when reaction is always, there must be a balance equation for that. So we should first write the balance equation between a copper carbonate and hydrochloric acid. So copper 2 carbonate, the formula will be CuCO3 reacted with hydrochloric acid, so HCl, form copper, because acid react with metal carbonate, it will give salt, so it will give copper 2 chloride salt plus water H2O plus carbon dioxide CO2 will be there. Then we have to balance the equation. For these equation, we start with oxygen followed by hydrogen and then any other element of our choice. So oxygen are 3, oxygen is 3 is balanced, hydrogen 2. So I put 2, hydrogen is also balanced. Then chlorine and copper are also balanced. So we have 25 cm cube of 2 mole per dm cube. So how many moles are there? For hydrochloric acid, moles is concentration into volume. So concentration in 2 and the volume is 25 divided by 1000. So means like 2 into 0.0525. What's the answer for the moles? Yeah, first we have to find, we have to use it. We have to work out. So how many moles of HCl? We got 0.05 moles of HCl. Then how many moles of copper 2 carbonate? So mass in grams. Moles equal mass in gram over molar mass. So copper is 64, carbon is 12, and oxygen is 16 multiplied by 3. So it will be 124 because 0.03. So we got 0.03, 0.0299 or 0. So what, according to equation, 1:2 is a ratio. Like if I have 1 mole of copper carbonate, I need 2 moles of HCl according to equation. But according to question, I have 0.03 and 0.05, like copper carbonate and HCl. If I take a simplest ratio between them, I'll divide by the smallest value. So when I divide by smallest value, this will be 1 and 0.05 divided by 0.03. What's the answer? 0.05 divided by 0.03. 1.67. 1.66 is there. So according to, yeah, 1.67 or 1.7, you can round off. So according to equation, 1:2. According to the values which I have, 1:1.6. So which one is less? Which one is less? So HCl is less, so it means HCl is a limiting reagent. So HCl is a limiting reagent. Now from HCl, like using the moles of HCl, you will find the moles of carbon dioxide. And from moles of carbon dioxide, you will multiply by the molar volume, which is 24. You will get the volume in decimeter cube. Is it clear? So we compare the ratio of the equation with our ratio. So A will be the right answer at the last. Is it clear now? Question 1. Question 3, 4, any doubt? Question number 3 or 4. Question 3, 4. Okay. Question 5 and 6. Any doubt? Question 5, 6. Question 7. Question 7 and 8. Okay. Okay. Question 7. Combustion is given. Which expression gives the standard enthalpy change of formation of methanol? Look, the term formation, what it refers to, formation means when element form a compound. So if I have a carbon, I have hydrogen, and I have oxygen, and they all react and they form 1 mole of a methanol. CH3OH. And 1 carbon I need 4 hydrogen, I need 1 oxygen, so I will write 1/2. This I will call formation. That is what I need because when element form a compound formation. But the combustions are given to us. So if I burn carbon and hydrogen, what I will get? I will get carbon. If I burn carbon, I'll get carbon dioxide. If I burn hydrogen, I will get water. And remember, this is given for 1 mole only, like when 1 mole. But how many moles of the water will be produced? It will produce 2 moles. If I burn methanol, it will also produce carbon dioxide and water. Now, if I apply the Hess law here, where the 2 arrows are, or first I'll write the numbers. As you can see, so if I burn the carbon, what is the enthalpy change? Minus 394. So this is minus 394. And if I burn 1 mole of a hydrogen, it is minus 286. But how many moles of the hydrogen are burned here? We are burning 2 moles of the hydrogen because for 1 mole it is minus. According to equation, we are burning 2 moles, so it will be twice. So this will be the total energy when we burn carbon and hydrogen. If we burn methanol, 1 mole of a methanol, how much energy is there? Minus 726. Where the 2 arrows are pointing out, that is the start of the cycle. So this will be the start of the cycle. And this will be the end of the cycle. So if I follow route 1 or I follow route 2, I'll get the same energy. So if I write enthalpy change of a formation plus minus 726 equals to minus 394 plus minus 286 times 2. I will just simplify. I will move this other side because it will be plus minus minus. So I move other side. It will be positive. So the final answer of formation, it will be minus 394 plus like minus 286 times 2 minus, because it was plus here, so then it will become minus other side. Like this was plus, it will become minus and minus 726. That is one way of doing this question. So what I will get because it matches with C, so C will be the right answer. That's one way. There's another way, as I explained to you, this is a Hess law. When I burn them, I'll get a combined product. There's also another way, which is CRP. If a combustion is written, it will be the reactor. So when the combustion is given, when we are burning a substance, so it will be the reactant minus the product. Like remember that rules. I told you if you can do it directly, it is CRP. So reactant minus the product will give you the same answer as this one. Or the second way you can form the equation, and how to form the equation is like because you need a formation. What you need a formation? So formation means when element form a compound, we call that as a formation. In the CPR is the like what we will do in this case. You can use a product and like when a combustion is given, you have this product is there, and you have the reactant is there. So it will be product minus the reactant, CPR. I was writing CRP, but CPR, product minus the reactant. So what I have a product, I have carbon dioxide. So I have a carbon dioxide. For carbon dioxide, it is minus 394. So I wrote minus 394. For water, another product is water. It is minus 286. So plus and then minus 286. But how many moles of water? 2. So multiply by 2. Minus the reactant. So what is the reactant? Methanol is a reactant. And the combustion of the methanol is already given to us. So it is minus 726. So this will work, or as I mentioned, the Hess law, that because the formation of a methanol we need. When formation of the methanol we need, so first I should write an equation for formation. What will the equation for formation? Formation means like element one side and the product other side. The compound other side. So methanol is a compound which is CH3OH. And what are the reactant? I should have carbon here, I should have hydrogen, and I should have oxygen. So I need 4 hydrogen, so I wrote 2, and I need 1 oxygen, I wrote half. This is what I need. That's a formation. But if I burn them, if I burn a carbon and hydrogen, so it will give carbon dioxide and water. If I burn methanol, it will also give carbon dioxide and water. So that's how I form the equation. So reactant form a product, product form the combustion product is same as reactant directly form the product. Is it clear, this example? So you can use the Hess law, or you will remember the direct method. If a combustion is written product minus reactant, if a